Good morning, good afternoon, and good evening, wherever you are. We welcome you back to another roundtable with CIQ. Today, we're going to be talking about software in an HPC environment, and we have a great panel of people on with us today. Go ahead and let them join. Excellent. And we'll probably have one more here in a minute, maybe not. So I want to go ahead and start and have everybody introduce yourselves. I know, I think everybody's been on here before, but let's start with Jeremy, if you would introduce yourself again. Nope, can't hear you, Jeremy.
There we go. Can you hear me now?
There you are. Yeah, absolutely.
Okay, great. Jeremy Seidel with Intel Corporation. I also represent the Open HPC project, and I've been a HPC systems engineer, software engineer for going on 20 some odd years now.
Excellent, thank you. Chris.
I'm Chris Stackpole with Advanced Clustering Technologies. We are a turnkey solutions integrator for HPC systems.
Thank you, Chris. Dave.
Hey everybody, I'm Dave Godlove. I am a solutions architect here at CIQ, and I've got a background at the NIH, working as a scientist and also as a support scientist.
Excellent, thank you. Alan, welcome back.
Thanks, Alan Sill, Managing Director at the High Performance Computing Center at Texas Tech University, one of a group of co-directors of the National Science Foundation's Cloud and Autonomic Computing Industry University Cooperative Research Center. And my background is in particle physics. I just got too close to the computing flame.
Thank you, Alan. Jonathan.
Yeah, my name is Jonathan Anderson. I am also a solutions architect here with CIQ, and I have a background in HPC sysadmin and systems engineering, mostly at central services organizations.
Thank you, Jonathan. John Grisnock.
John Hanks, the HPC sysadmin in the life sciences mainly. Mostly here to tell the kids to get off my lawn.
Appreciate it, John. So let's go ahead and dive in. And I think there's a couple different ways you can look at software in an HPC environment. We'll let Glenn introduce himself. I think everybody's seen Glenn before, but since he slides in late, we're going to make him sing a song or do something fun. I'm kidding, Glenn.
I was going to introduce myself with a performance dance, but I probably don't want that. Glenn Otero, recovering scientist in the life sciences, bioinformatics, scientific computing director at CIQ for genomics, AI, and ML. And I am a borderline boomer, so you can all just get off my lawn.
Appreciate it, Glenn. All right, so back to what we started before Glenn interrupted us and came late. A lot of different ways you can look at HPC software. So from a systems environment, from a sysadmin perspective, and from a user perspective, and I think it's interesting the way that things are progressing and kind of, I know Jonathan and I talked about this quite a bit, the way containerization might be helping or changing or making it more complicated. And that's kind of what I wanted to talk to you guys about today is, how do you see that landscape? What does that look like? And we've been doing the same thing for a long time, but things are definitely changing, and you guys have different experiences than all of us. So I'm curious to hear from each of you. Like Jeremy, from a software perspective, what are you seeing today?
Well, actually, you brought up a really interesting point on containerization, because one of the systems I'm supporting right now is built entirely around containerization, and that is the expectation that the users will provide their own containers with their own jobs. They package up their own software, they bring it, and what they get is a set of nodes that are really absolute bare minimum installations, and then they're expected, they run their containers on top of that, and then the nodes are completely wiped. And of course, they're running with using Docker containers in order to keep the security intact. Basically, it's not only just you wipe the systems and reboot them.
It's very interesting. Thank you. Yeah. Chris, what are you seeing today when it comes to software?
I have an interesting kind of perception on it, because a lot of our customers, they are looking at just the life cycle of their cluster, and the research that they're doing impacts now. They don't have a whole lot of long-term stuff. So it's build it for the cluster they're built right now, and then they'll run that for the life cycle. Then next cluster, build a new system. But I've also done a lot with researchers that are writing papers that may be 10 years before the life cycle of the paper really starts to be challenged and reviewed. And in that case, I've been that admin where I've been asked to install applications and software 10, 15 years old on a modern HPC system in order for them to verify the results that they ran then, because it's now being challenged. And can they get the same results from that paper? And that is a very hard problem to tackle when you're being asked to pull in libraries that haven't been supported since RHEL 4 or 5. And so a lot of the containerization focus that I've done in the past has been with some of those long life cycle applications, with the hope that 10 years from now, when those same researchers are being challenged on the papers they just wrote this month, it's going to be a whole lot easier for us to verify those results.
Sure. Before I move to Alan and John, I want to ask you, Chris, so whenever that type of thing is taking place today, is it really your responsibility to maintain and keep those legacy libraries around, or are you pushing that back on the researcher and the end user? Like, how does that go?
Well, the number of times I've thought, man, past me was such a jerk, why didn't he do this better, is pretty high. And so a lot of it is how do I make my job easier in the future? I mean, that is definitely a motivator. But working with a lot of these researchers, we're seeing where, the long tail of HPC is just growing longer and thicker. And so people who, 10, 15 years ago, they didn't even know how to spell HPC are now being asked to run their jobs in HPC because that's the only place their data can be big enough to run. And so they aren't computer scientists. They don't really have an interest in learning HPC. What they are good at, though, is their job and their specialty. And so they know their code, they know their research really, really well. And so it's from an admin point of view, how do I help them so that when they have this issue in 10 plus years where I have to revisit this code, can it run? Can I help them, or anybody who's trying to verify their code, ensure that it's actually working? One of the issues that we had, a real example, was where they were being challenged on some of their paper because they were very ahead of their time when they wrote it years ago. And I was trying to rebuild library sets from EL5. And we were actually finding some variation differences depending on if we ran it in a 32-bit container VM or a 64-bit VM. The libraries did not behave well because of the libraries at the time. And trying to get the exact same version of the library to get exactly the same results was very, very challenging. Mm-hmm. And so the hope is that I don't really care what it looks like in 10 years, but having it packed up inside an image type of a container, there's a high likelihood that I will be able to better match that library set for them. Because it took me weeks and weeks to recompile these old library sets that haven't been supported in so long and trying to get them to match exactly right. And for the end user or researcher, that's too big of an ask. And so it's, and we hear this all the time, especially the last 2 years, the reproducibility of papers in science. And can we actually reproduce these papers? It keeps coming up because somebody has all these crazy assumptions that are made, and then nobody else can reproduce them. But yet that impacts media, that impacts decisions. We've seen a lot of that where rushed research or impartial research made bad decisions that impacted a lot of people. And so we want to make sure that when we are doing reproducible science and have reproducible data, that it's as reproducible as actually possible. And a container really helps in those environments for those researchers.
It's great. Thank you for that, Chris. Alan, I know we've talked about containerization some, we've talked about software some, so give us your view.
Yeah, so it's sort of like I'll make a food analogy. It's when I travel to Italy, I'm always shocked how quickly Italy totally reprograms you as to what you think, food and drink should be. Inside of a week, you're discussing the fine points of Ligurian versus Tuscan olive oil, and think the coffee should come in those cups and stuff. So when you start to use containers, you start to think, well, why isn't everything in a container? So let's tick off very quickly some of the reasons that some have been mentioned. Reproducibility, though, let's come back to that. You can even get a DOI for your image. You can store an image like a single file, so it's storable as opposed to long list of build instructions. It's portable. You can run on different machines with the same image. You can run images with different operating system versions than your operating system version, as long as they share certain kernel characteristics. Keep in mind that the fundamental design concept of a container is unsharing shared namespaces and memory, right? It's an unsharing technology. So it lets you isolate yourself from some details as long as the kernel is compatible. And we can come back to that and talk about MPI, for example. You can bring your own software, you can build it. So you look at all this advantage, you think, why isn't everything in containers? And maybe CIQ has that in mind. But surprisingly, not all food is Italian, and not all food is, not all software is in containers. So despite some obvious advantages, there are some things holding people back, and it's worth examining some of what those are. I won't make the full list, but I'll just hint, vendor-specific software often doesn't support installation in containers and so forth. I'll stop there.
Absolutely. Thank you, Alan. John, I think you've probably got an interesting perspective on this as well, managing some large and dispersed environments.
Yeah, my current environment has been completely different from all environments in the past. In the past, I've had modules set up and had like 1,600 plus packages in a module tree to support environments. But I've been running this cluster about a year, and we've had almost no software requests whatsoever. Pretty much everything people have done, they've brought their own. It's been a mix of containers and just software installs, mostly Anaconda environments. But the extent to which all software is going into Anaconda and containers is, I've been flabbergasted by it. I never would have expected it from the beginning, because my view of containers is like, you tell me I swam across the English Channel. Well, fantastic, you swam the English Channel. And then you say, somebody else comes along and says, I got on a boat and got in a lap pool and I swim laps while the boat drove across the English Channel. Well, good for you, but that seems like a lot of extra work. You could have just swam the English Channel, right? So that's kind of been my historical view. But yeah, it's, from my perspective, being an admin on the software side is getting easier because more people seem to be self-supporting than they used to. On the occasions when I do have to get involved with installing software, though, software quality overall seems to be going down to me. Things are really complex. There's a great XKCD cartoon where he's basically got all of civilization, and down at the bottom there's a little tiny piece that says a Mpi package. It hasn't been maintained in 12 years or something. And all this stuff that's getting jammed in containers today on the idea that things are going to be reproducible, I don't think people are admitting that time actually flows forward and things change, and you're containerizing bugs and security holes and all this other stuff. Is it really going to be valuable? I think to the extent that doing it today gets you a paycheck, great. But in the future, I don't really see people dragging these things out in 10 years to try to reproduce something. And in any case they did, it's not scientific reproducibility. It's digital reproducibility. And to me, that's pointless exercise. I don't really care about digital reproducibility.
Interesting. Thank you. Glenn, I'll go to you next. You've seen some stuff.
Yeah, it's actually just thinking about it, it's been kind of interesting because I've been of the mind that, yeah, we need to use containers for for all the reasons that people just stated, right? The reproducibility aspect, kind of the fossilization of a moment in time that you can go back and reproduce. But just been thinking about seeing the container use by the bioinformaticians. It's actually kind of in the reverse. They're actually kind of trying to live in the future. So they're just always downloading the latest, greatest bioinformatics app or the latest, greatest release to rerun their pipeline, make sure, find one more variant, validate the research a little bit more that, they're on the right track, and trying to pull stuff down that, or run something that someone built on Fedora, but you're running, you're running on Rocky kind of thing. And so really just using it as a time machine to go forward on a production cluster, but really with not much thought of like, oh yeah, I should keep this container around and give it a DOI, and because this could be there for reproducibility for other people. I don't think they really see past their own lab, their own work, and again, just trying to pull down the latest and greatest app and get it to run where it normally wouldn't on their laptop or on the clusters they have access to. Kind of one of the reasons I think cloud also is kind of caught on a lot there as well, is just being able to run all this latest, greatest stuff. Again, don't think about security. Don't think about, what's going to be supported in a couple of years. Ditto for all the, Anaconda environments, right? You better keep that YAML file around, but good luck, rebuilding that environment in just a year, right? So I think it seems to be a little like a two-edged sword. And I think it's more of I think it's necessary. I don't think it's sufficient.
John, did you have something you wanted to add?
Yeah, Glenn actually reminded me, I left out my absolute favorite aspect of containers, and to me, the absolute biggest positive of containers. Software developers will often refuse to write decent installation instructions, but if they containerize it, by definition, they have written installation instructions, which I can steal and go use the stuff outside of a container. So from that perspective, I do like containers because it motivates people to write decent install instructions that will actually work.
It's true. Thank you. Dave, Mr. Container around here. I know you've been spending a lot of time working on containers lately and trying to containerize some stuff. So, we've been through this before, and from a researcher perspective as well. So what are your thoughts on all of this?
Yeah, there's so many interesting thoughts that everybody just had to riff on. I'm taking notes here like, oh, I want to get back to this and I want to get back to that. So I don't really know where to start. But I guess two main threads here from what I'm hearing are, reproducibility, which we're talking about, kind of later here. And then a little earlier, we were talking more about, helping users and empowering users and allowing users to install their own software. And I guess maybe I'll comment a little bit on that. Coming from the NIH, the team there has this really, really great attitude about the users, about the scientists, and that is that these scientists, they're brilliant and they know so much about their domains, and there is so much to know and so much work to do that they can't possibly be expected on top of that to become computer scientists in addition to everything else they've already done. So it is our job, to take these biologists and these folks who are into all these different sciences and are very deep into them and know tons and tons of stuff that we'll never know, and help them with stuff that they might not know and don't have to. And so I wonder, are containers helping with that? They can help with that and they can hurt with that, right? Containers might make scientists' jobs harder down the road, because we might say, okay, here's a cluster with a container runtime, have at it, right? And some scientists might be fine with that and be fine with building all their own containers, but it's kind of just offloading a lot of the sysadmin work, or maybe a lot of the application support work, off to the scientists. Is that okay to do? Is it not okay? I guess it kind of depends on the situation. And then another thing too is that when containers first hit HPC, we thought that that's what they were going to be. All scientists were going to end up building their own containers and using package managers and such inside the containers to build all their own software and have everything, and that's not how it's turned out at all. How it's turned out is that Other folks, third parties, build containers and put them up on Docker Hub, and end users just download containers. They don't actually build them. So maybe in that respect, it actually is helping the end users quite a bit. So just a lot of interesting things to talk about and think about. And then on the reproducibility side of things, I mean, one thing to note is for scientific reproducibility, distribution, collaboration, things of that nature, often another lab doesn't want to take somebody's workflow and data and just press a button and see that the same figures pop out. I mean, it might be like reassuring to some extent, but what they want to do is they want to take their own data and maybe get the code base, and they want to modify the code base a little bit and push it forward, right? They want to be able to look at this stuff and edit the code and use their own data and do things like that. Do containers help with that? Because they might help with that from the perspective of being able to push the button and run the workflow and get the result. But then after you're done, you're like, okay, now I want to crack it open and look and see where the code's at and what's going on and how do I modify it? And if you're not a container expert, or a file system expert or whatever, it can be a pain to get inside that container and start digging through it and figure out where all the bits are and what makes it run. So I don't know, just random thoughts based on everything that we're just talking. I got a million more, but I'm going to cut it short in the interest of letting other people talk.
That's interesting, Dave. I hadn't thought about having to go back and actually change the code. So once you have to crack open a container, that is an interesting point. Thank you. Jonathan, I saved you for last.
Well, actually, I see Chris raising his hand. I would like to hear.
Sorry, Chris.
No worries. Just on that point, there are actually something I've witnessed a lot with some of the researchers is that when they are trying to reproduce, they do want that first round to be, can I reproduce it exactly as it was published? Because there's a huge difference between attacking a paper because the data or assumptions is wrong versus that the methodology was wrong. And so if I can prove that the methodology with the data matches correctly, then all of a sudden I can say, okay, your ideas and concepts, these are what we need to actually focus on. If you had looked at this problem from this view instead, that makes a huge difference than just saying, well, I got different results, and so therefore your whole paper is worthless, which actually does happen quite a bit when people can't reproduce the results. And so part of being able to get that initial, click a button, download it, and get the exact same results means that I'm now at least mimicking exactly what the paper author had, and I can reproduce their results. So now I can go ahead and critique what it is about the paper that kind of actually makes sense about, like, how do I adjust this? How do I tweak this? Can I look at this problem from a different view and get a different result?
That's a good point, Chris. Thank you. Okay, Jonathan, we've talked about this quite a bit. We've talked about this quite a bit lately. I know you have some opinions on this and why it is good for containerization. So
so I compare this moment in HPC and scientific software containerization to, and this isn't necessarily my original thought, but the thing that's most useful to me is to compare it to the advent of data center automation and infrastructure as a service, like we saw with the large cloud providers, AWS and Google and Azure and all the others. That virtualization is an interesting technology, but the game changer there is that it takes something that historically only a subset of people could do, the sysadmins in your organization who had the rights to the data center or who knew how to do it. It takes something that only a small group could do and turns it into something that anyone can do. And not that everyone does, but it simplifies the workflow of setting up a server to the point where now the sysadmins, or if they're in a virtualized environment, are doing things very similarly to any random person who might want to spin up an instance in an infrastructure as a service environment. I see containers that same way in this conversation. I've been doing a lot of work figuring out the best way to containerize MPI applications, for example. And my thought process on that is not, and now the sysadmins or the support people will never install another piece of software again, but that now anyone can. And so someone mentioned earlier that, you know, it hasn't been that all of the scientists just build their own containers, but that third parties do. And because anyone can, that doesn't even just mean your users. It means you can run containers from wherever. And now you can draw value, not just from the people running your cluster, not just from the people that work on your cluster, but from anyone who's building any container of a certain type. And you can pull it down and run it. One of the things I highlight in some of my MPI container demos is that there is nothing special to the environment I'm running this container in this container. I can just pull it down. Like I pushed it up to Docker Hub because why not? And I can pull it back down and run it. But as long as I had Aptainer on a different cluster, I could run it there too. There's no dependency. And I think the biggest win to me, I totally agree, by the way, with John's pointing out that a big value is the containerization of the install instructions and self-documenting how a container works. And that breaks some of my brain because I'm a systems guy and I really want things to be kind of declarative and very well specified. And the fact that containers are really just a kind of fancy shell script dumped in a file bothers me a little bit. But when I get over myself enough for that, I realize that's how most people share sysadmin knowledge when they're not sysadmins anyway. And so it kind of flattens that landscape and lets everyone talk that same language of here's just the raw stuff that it needs to do. And then you package that up and do it once and you can hand it around. And I think that's really cool. And so yeah. I'm looking forward to more of that. Not that I think that all of the users on all of the clusters will always containerize all of their software. But since anyone can, it only has to be done once for anyone to be able to use it and get value out of it.
So before we go on to the next topic, Zane, I wanted to highlight a couple of things that we've mentioned, but are there like rocks under a stream if you're kayaking, right? The MPI topic is better. It's in the sense of Monty Python's "You Turn Me Into a Newt" getting better. You know, it's still a problem. The MPI standard itself, the whole range of them, is trying to converge towards interchangeable MPI, but we're not there yet everywhere. And so, as I said before, anything that goes to the kernel to make its call, you have to ensure compatibility between the kernel and the containerized version. If you've had better luck moving Aptainer containers around, I want to hear more about that. Maybe you guys can post about that. Through this thread, there's been a sort of a line about reproducibility, and I put into the private chat a comment that I'll just say here publicly. That friends of mine who study reproducibility say that it's far inferior to transparency. And so, as Jonathan said, the great thing about a container is the recipe is right there in front of you, and the transparency is there. So, for example, there's been a lot of security concerns about software bills of materials, software SBOMs, right? Sort of a bad acronym, but yeah, so software bill of materials is supposed to ensure that if you have a security problem in a software chain, you can figure out what's dependent on it. But usually that concentrates entirely on the built software and not on the operating system dependencies that were hidden there, like glibc and so forth, that the software is equally dependent on, but won't show up in an SBOM. A container in principle can do that, but you have to go back to that rubric. Are you getting transparency, or are you getting researchers downloading black boxes because they say they have a piece of software in them? So if you can do what Jonathan said, great, because you have both reproducibility and transparency. But if people are just treating this as a black box, and you're carrying security problems along with you and so forth, you haven't won.
Thank you for that, Alan. We do have a question. I think we're going to pop it up. I think Greg kind of responded to it, but Martin asked, can a researcher get a simple route to containers via something like Spack? And I know, Jonathan, we've talked about this as well. I think it's interesting for you guys. I mean, Greg has answered yes. I kind of think this leads into the next question I had for you guys, but I'll let you answer this one first. And Jonathan, since we've talked about this recently, I'll let you.
Yeah, so I've experimented with this a little bit. And absolutely, you can start a base container and as part of your build, install Spack in it and build software in it. And I have definitely done that. One of the downsides to doing that is you lose a lot of the caching benefit of Spack, where building software takes a long time sometimes, especially these scientific applications. And so part of building containers is often rebuilding them over and over again. If you're throwing away your Spack build cache every time you're rebuilding a container, you're losing a lot of the benefit that you would get out of something like Spack. I personally, more recently, have been using the OpenHPC project for this instead, and using the software that's already compiled there, rather than building software unless I absolutely need to. But I also, as an experiment, nothing production has come out of this yet, but I took advantage of Apptainer's support for Sandbox containers, where you can have a mutable directory instead of a kind of zipped up single CIF image, and used that as a base for my Spack builds, and then built subcontainers off of that. So you can, but if the point was to simplify it in the beginning, you're kind of off in the weeds if you're doing something as bespoke as that. My general recommendation would just be to use what people have compiled already.
So let me push back on that just a little, because we use Spack a lot here, and I don't know if people have noticed this, but the Exascale computing project has been publishing a single container built automatically through CI/CD processes regularly. I don't know if it's nightly or what frequency, or if it's on demand, but of all their software. So basically they have this thing called E4S, the Extreme Scale Scientific Software Stack. Oh, I actually remembered it. So E4S, you can actually go there, you can hit the downloads button, and you can download a whole container. And I've done this. The software, some of which is extremely complex and difficult to install yourself, will run out of the box on your machine. Okay, what are the downsides? Well, it's a 50 gigabyte container. And beyond that, there's a very strong qualification for any software project to get into the E4S stack. So I would say 3/4 of the software that our researchers depend on daily here isn't in that stack. This is software that's been qualified to run on exascale machines. But let me wind back just a little and say, that's an interesting idea to build such a container simply for versioning and testing, as you just hinted. Suppose we're going to change the Spack version, or we're going to go to a different operating system. It'd be great to have a CI/CD process that built all of our apps in a container that we could use for testing, whether or not we actually intend to download that one single container to all of our worker nodes for any given revision. So I'll just summarize this by saying one of the big potential advantages of containers, especially if we can use these sandbox style ones, would be for the difficult job of version testing. So, if we have a certain set of built software that we support on our cluster, it'd be nice to get a head start on the next operating system release, the next Spack version, the next MPI, whatever. And you can do this with single bits of software with Spack, but it's harder to do the whole thing.
Thank you, Alan. And I'll come back to a point you made in just a second, but we have a question I want to ask real quick, and then I'm going to get back to that, Alan. After 30 years of HPC style, or of Beowulf HPC style, why is deploying cluster software still complicated? Or is it really just the management over time and image drift that's complicated? I'll open that to anybody who wants to jump on first.
Oh, I'll offer my opinion on that. I don't necessarily think it is complicated. All my software stacks over time have always been just, I built it and installed it, including all the complex stuff back when I did real HPC back in the day. And it wasn't complicated to do, but it required a lot of patience and knowledge that I learned by getting smacked in the face over and over and over again by things like Wharf and Fortran 1 underscore, 2 underscores, 3 underscore, whatever you're going to do to get things to link. So for somebody who climbs the learning curve, software is not necessarily hard to install, other than to the extent developers do a really bad job of documenting it and giving you the information you need. So you have to reverse engineer a lot of it. For making that simpler with Spack and Easybuild and stuff, I've avoided those because every time I've looked into them, I've wound up feeling like they were hampering me from installing software as fast as I could on my own. The extra layer, if something will compile with configure, make, install, I don't need Easybuild and Spack. If something is so complicated that every release is changing the build options, then again, I don't need Easybuild and Spack. It's got to be fixed there every time too, right? So I don't need those. But it's kind of a general overview of this kind of thing. Tools that attempt to take the complexity out of it, I think, give people a false impression that they know what they're doing. And if you give a doctor a scalpel, that makes him a surgeon. But if you give some random person off the street a scalpel, that makes him a butcher. And, maybe not everybody should be installing software. I'll just throw that out there as a possible option for the way the world should work.
Oh, that's a great point, John. Thank you. Jeremy, you're nodding. I'll pick on you.
Yeah, I was going to say the having installed cluster software for the last 20 some odd years, I don't think it's more difficult. In fact, I think it's a lot less difficult now, and it's not just experience. It's that there's been a lot of work into simplifying a lot of the tasks. Where I still stumble continuously, it's the combination of fabric software, MPI, and the application all working together. And I think that's just a lot of I think John pointed out it's software quality. Are the software developers following the standards set forth? Are they making those standards transparent? Is their software fully tested before they're actually putting it out? Because I certainly encounter that a lot. But HPC is still very much an open source software project. I represent a very large open source software project, and a lot of the software I certainly feel a lot of software goes out before it's, I think, ready to go out. And that's, I think, where I think a lot of the issues come in. But certainly having to work on like the Werewolf project, that's with that in place, I think it's very easy to install software across multiple systems, because that's really what it is. Instead of installing software on one system, you just need to install software across a variety of systems, and then obviously getting it working is difficult if you're talking about multiple pieces distributed by different entities and software developers.
Sure, makes sense. Thank you, Chris. Absolutely.
So I'm kind of a mixed opinion on this. I think in a lot of regards, it is a lot easier these days than when I first started, because there are tools such as like Spack to help through some of the really complicated builds. And there's also a lot better communities for even when the software itself is not as simple as just doing, make, install. The communities there give a lot better documentation. But at the same time, there's also a lot more challenges, especially if you're not dealing with the latest and greatest. For example, recently, trying to help a researcher out and confirming if his code was still functional, that he was dug up, and the last time it was compiled was with Intel 2016 compilers. You can't find those, and Spack lists them, and Spack fails because when Intel released one API, they killed all the download links for the other versions. You can go pester Intel, which is what we had to have them do, and then you're in a support loop because none of the first level support guys have any clue where to find a download for 2016 compilers. You're just hosed. And a lot of that complexity is still really frustrating. And there's also an aspect of if you are doing some precompiled stuff, it's fairly easy. You want to spin up Kubernetes on a cluster for some work. Well, great. You look at the stuff and they say, oh, grab K3s or Minikube. And you're like, well, no, I need actually something more than that. If you've tried building Kubernetes, it's a pain. There are so many pieces. And part of that's because it's a complex piece of software. And I think a lot of HPC tends to get that way. You do the make, install, and it's great if you're running it on a single node. But when you want it to scale across multiple nodes, working with, Nvapich and a CUDA driver, and all of a sudden the complexity of the build goes up way high. And so when the community has figured out some of these build scripts and they integrate that into Spack, makes it a lot easier. And I think that while the target audience may be somebody, just the guy off the street with a scalpel, anybody can do it, I have a feeling that a vast majority of the time it's just they're giving it to a doctor to help with it. That there's still a sysadmin who needs to kind of understand how it's compiled, where it's compiled, what options are best to pass to it. The Spack has a lot of variables that you can pass to optimize, and a lot of that stuff you need to know your system in order to optimize it and build it correctly. It's just a helper to get through some of the really complex stuff, and that's where the community really has stepped up, and I think is one of the things that makes compiling and dealing with software these days so much easier than it was before. There's a bigger community that's more eager to help.
That's great, Chris. Thank you. Jonathan, I'll let you have the last word on this, and then I kind of want to go back to something Alan mentioned earlier.
Yeah, I think one of the things that's driving improvement in this area is the broadening of the audience for HPC software. And some of that is coming from the supply side, where the tooling is getting better and the software is getting better and the software is more applicable to people. But the other is just as applications that we wouldn't have historically considered HPC applications and use cases become HPC use cases, we're getting more eyes on it. Open software it's anti-fragile in a sense that it improves the more people experience the pain that is in it. And scientific software has been in a kind of bad niche for a while, where a research scientist or a computer scientist got something working and it worked in his environment, and they're like, great, it works, and they publish it. And now it's on the staff at all the different HPC centers to get it to work in their environment. But the only people feeling that pain is that initial developer and then the people in the sites. Containerization, among other things, drives the need to be able to show how it worked, how you got it to work, and to make something else be able to get it to work reliably. And when other people are using this software, they're having to do it too. So the more people are using the software, the better the installation processes are going to get, the easier the management of it is going to get. And I think that's going to be more the solution, is more eyes and more hands on it than one tool that will fix it.
Thank you, Jonathan. And we lost Alan, but kind of back to what he said earlier. He mentioned a large container, and I think it was like 40 or 80 gig. I've heard of some research scientists or some admins actually going and using something like Spack, and they'll tell it to compile every different version of everything that they could possibly think of on every different compiler to try to cover everything. So it doesn't matter what environment it goes into. And I've actually heard of people having 250 gig containers that come out of this. And then you're stuck with, I have this massive container. At what point in time is it too much? And that kind of goes to John's point of, yeah, you've made them butchers. Now they have this massive thing with everything in it. Do they need it? No, but they have it. So what does that do? I mean, where does that line need to be drawn, and how can we help with that?
I can share something that I butcher frequently. Our module in our software stack, we build every package from CRAN and Bioconductor that will build non-interactively. So if you load up our R and you count the libraries on any given install, it'll be somewhere between 17 and 22,000 packages that are in our R module. And it's mostly because we want to make R, to the extent R can be made painless, completely painless for the people that use it. We don't want anyone to have to ask us to add a package to it or have to install a package themselves in their local directory. that all leads to problems. That makes our software stack absolutely enormous. That's even before we get into Anaconda, but a single R install for us sometimes will be 300 or 400 gigabytes.
And is that something that you think, I mean, when you look at a container, that becomes difficult to move at some point, right? And when is
That's
that?
not containerizable, I don't think. That never goes in a container. That has to be an NFS mount to a software stack with a module in front of it.
Yeah, we're sort of glossing several related issues that center around what happens with the software, regardless of whether you put it in a container or not, depending on how you're building and deploying it. So let's just pick, for example, Spack, because we've talked about it. One of the things that happens when you build software in Spack is that you lose the old paradigm of load library, environmental variables and stuff. Everything goes in an R path. So basically everything that has to get built, and they're getting better at detecting things that have been built already, but basically everything that's a dependency of that software goes in the R path, and therefore it goes onto the file system for that software. It's pretty hard to distribute that software to worker nodes by whether they're stateful or stateless. That's actually hard to pick up that built Spack library and copy it over. So what that means is it puts pressure on your cluster-wide file system, the portion that you're using for distributing software. We actually have a separate setup for that. We're just implementing BGFS. We had Gluster before, but it wasn't strong enough. NFS is popularly used. So that thing is getting slammed. Millions of open file handles, because every single thread of every single MPI application is opening dozens of file handles to stuff that's in your RPath. So we actually found that Gluster couldn't handle that at all, even though regular NFS can. So there are implications on how you build and distribute the software, independent of whether it's containerized. One thing about a container is it's a single CIF image. When you move it, you're moving it into essentially local memory. So those dependencies go away. And it can be a way of circumventing that dependence on the cluster-wide file system, but at the cost of chewing up your memory or local. If you have enough space to turn on, swap files, local swap files we don't. So we have very tiny disks. This is just one sample among many. Python has similar considerations. So independent of build libraries, how you deploy the software, R is another example. You can get not only huge libraries, but huge numbers of file accesses for every single one of those Python execution points to the .pyc file that's in there in that R. Across your cluster, it can be a huge bandwidth issue.
Thank you, Alan. Dave, I think you had some thoughts on this as well before I go back to John.
Yeah, so going back to your original question, you're basically talking about like how big should a container be before you sort of draw a line in the sand and you say, okay, that's too big. Let's figure out how to make your container smaller. And I think that what that kind of gets to is best practices. And I kind of have a pet peeve when people start talking about best practices, because best practices come with an assumption. It's like, best practices for what? Best practices for your application, for my application, for what, so containers are a very, very powerful tool. And whenever you build a really powerful tool and you give it to somebody, they might use it for something that you didn't have in mind. And that is actually, it shows how powerful your tool is, that somebody can go and adapt it to something totally different that you never thought of. And so in some, one of the things that I containerized in the past was we built a TensorFlow container, and the TensorFlow container, it needed to be compiled two different ways, one with AVX instructions and one without, so that depending on which node it landed on, it would run intelligently. It would either run with AVX or not run with AVX, and not just bomb out and not work. And so we called that a fat container, like a fat binary, right? That has multiple different ways of running. And so I just, I hesitate towards putting limits on and telling people that they ought to build their containers this way or that way, or whatever. I mean, because you don't know what they're trying to do, and maybe a best practice for your application is not a best practice at all for somebody else's application. So I don't know. That's just how I kind of feel about the whole really big fat container thing.
Sure. Thank you.
I guess one more really
Yeah.
quick thought too. We were talking a little bit about why is it still so hard to install software in scientific environments, and this makes me think of a story. So I brought my nephew one time to the Air and Space Museum in Washington, D.C., and we were looking at this really early satellite, and you could tell that it was like handmade, and like it was put together. It had like writing on it, and people had like stamped things on it and stuff and everything. And my nephew was looking at this, and he's like, this is supposed, and I'm like, this is high tech, and he's like, this is supposed to be like high tech, and he's thinking about, like television programs like CSI and stuff, where you're bringing up computer screens in the air and you're doing stuff, and I'm like, so I used to be a scientist, and I said to him, look at this. This is what science looks like. You don't manufacture science off an assembly line. It's not shiny and pretty, and it's one person or a small group of people hand building stuff, prototypes that look ugly, but they work. And this is why it's so hard to install software in scientific environments, because a lot of times your software is just a prototype. There's no packaging involved. There's no, these are people that don't necessarily write code as their primary job, that are in a lab trying to make their code, analyze some data, they get it to work, and then they publish it. And it's your job to take it and figure out how to install it in your scientific environment. And it's handmade, So that's my hot take on why it's still hard to install code in scientific environments.
That was great, Dave. Thank you. John, I think you had something you wanted to add.
I did, but Dave just prompted something that I remembered. I'm definitely guilty of making fun of biologists who write software. Like, biologists are terrible at writing software, and I've had to support a lot of really bad software. But the one thing I will say in their defense is, at some point they stop and they're done with that piece of software. An actual developer will never stop making it worse. Like, developers won't stop. You will never find a developer who will put on their performance goal for their year, I'm done, this is perfect, I don't need to do anything, I'm just going to sit here and draw a paycheck, right? They will always keep developing. And somewhere between the grad student finishes their master's and never touches the software again, and develops forever until they make the package impossible to use or work with, somewhere in there's a sweet spot. And I wish we could find that sweet spot.
That's a good point. Thank you, John. I have several questions that are coming in. I know, Todd, is it the one we're going to pop up first? Oh, so Martin asked, are any of the panel members, have any of you guys ever used Gen 2, like Easybuild?
Used it in the past, have it in a while.
Yeah, same here, though. I did think of it in this particular context years ago when we were trying to build software and find a way to automate it. I wondered why someone didn't just take either Easybuild or ports from BSD and port it for use in scientific software applications. They are quite different in the particularly multi-versioning and multi-builds of the same thing, which is why Easybuild and Spack exist now.
Thank you. Another one from Todd. There we go. Can commercial software like Ansys be containerized? Hot topic around here lately.
I would say talk to your legal team and talk to the vendor. I don't know about Ansys specifically. I know of them. I just don't know if they would allow containerization. There are third-party commercial products that have specific rules for how you can do containerization. And some of them are very public about, like, hey, here's what you have to do to fulfill this. Others, when I was working with MathWorks for MATLAB, they were very concerned about having a MATLAB license that anybody could run. And so we had to work with our legal team and their legal team to basically say, yes, you can, but you can't include a license number. That has to be something that the end user has to pass through. I don't know if that's gotten better. It's been a couple of years since I worked with them on that. But there are commercial vendors out there that are doing stuff. And then there's others that you mentioned containerization, and they just kind of gloss over. One of the reasons why I really like supercomputing is I can go see all the vendors I work with, and I very often would go and harass them at their booths and be like, "Why can't I containerize your software?" Because there at SC, you tend to be dealing with people who know the field that you're coming from versus just a straight cold call to somebody who's like, I don't know. At least there they know what HPC is, and they have a better idea of why. So that's a great place to kind of meet up with some of those vendors. But yeah, that's a tricky one because it's all legal at that point.
Yeah, thank you, Chris. That's something we've talked about quite often is how do you do licensing with that from some of those vendors? So that's exactly what we've been discussing, Chris. Thank you. I don't know if we've had any more questions come in. So we're getting close on time here. Glenn, I feel like you've been quiet for a while. I'll give you first shot at closing thoughts then.
I think Alan brought up a really good comment or thought or theme on reproducibility being, much less greater importance than transparency. And now that I think about it, I tend to agree because the other thoughts kind of swirling around in my head with regard to reproducibility actually kind of originate from, I think, other sources, right? So it's and I'll pick on biologists again too, because I am one. The problem there started a long time ago, right? Not telling us how you prepped your data or cleaned your data and things like that, right? So, the program you're running almost didn't matter if you weren't telling me how you cleaned your data, what you threw out, the averages you took, the statistics you did, and also on the publishing side, right? What's accepted for publication, what the bar is set at. Publication is going through this huge renovation, hopefully, not just being open, but like having to publish your data, like Giga Science makes you do. The elite journals, what they accept, with regard to reproducibility and things there. So I think transparency kind of is a little bit more important there because with regard to containers, because reproducibility actually has, I think, issues that originate from other places in science, and not just giving us a container is not going to be a silver bullet there.
Thank you, Glenn. John, I'll go to you next. Closing thoughts.
I would just throw out a suggestion. People, admins, especially people who are beginning HPC admins, stay away from tools that try to do your job for you and learn how it works. Like, invest the effort in learning how things work. It will pay massive dividends down the road. And there are no shortcuts to knowing what you're doing.
That's good advice. Thank you, John. Jeremy.
Well, two thoughts. One, I thought it was pretty clear that if you are an author or a researcher publishing papers, if you're using software to do any of your results are based on software, keep a copy of that software and put it on the shelf because it might be needed. Save your sysadmins a lot of reproduction work. But the other thing, and I like to think that part of my job is trying to make life easier for sysadmins and end users. And there was this, this interesting comment that came up, said, looked at, we're not, by moving to a containerized model, we're not shuffling all the work off to the user. I think the difference is the users come to you now and say, I need this piece of software. I need you to set up the licensing server. I need you to configure it this way. I think the change is going to be they're going to start coming to you in the future and say, can you help me build my container?
True.
And so I don't, and to me, it's just a shift in work, but I think in the long run, it's going to be a lot easier.
I hope so. Thank you, Jeremy. Chris.
Yeah, I fully agree with a lot was just been said. I think it is very important to know how the tool works so that you can fix it when it breaks, because it inevitably will break. There will be an update or something that will break it, and you'll be responsible for fixing it. I caution the use of tools that you don't really understand some of that work because of that situation. And so they're great tools, especially if you are, the only admin for the HPC, and so everything's falling on you. The better you can reproduce your work so that when a new version of the package comes out, you can easily rebuild it and deploy it for your users. That's all really important. But understanding the process of how you get there really, really does help with updates, and even when you need to reproduce something and rebuild an old version.
Great. Thank you, Chris. Dave.
Yeah, it's just a really, really interesting conversation. Just to riff really quick on something that Jeremy said. I mean, I totally think that containers not only so they could be used for evil to sort of put all the onus on the users, but I don't think that anybody is really doing that. I do think that users ultimately might come to admins at some point in time and say, "Can you help me build my container?" And I think also that admins and support scientists and application scientists and so on are also kind of taking that step for the users in many cases. So a lot of times users come to you and say, "Can you help me install this complicated thing? I don't know how to do it." And then, as an admin, you might say, "Sure, I'm going to do it in a container. And by the way, I'm going to do it in such a way that you might not even have to know that there's a container there to use it." And so that's another great use case for containers, is just make the application engineer or the scientist or the admin's life easier as they support the user.
Thank you. Jonathan.
My main thing right now is just to encourage people. Like, this is an area of innovation, and there's cool new tools and new techniques that are being developed right now. And if you're interested in that kind of thing, looking for ways to get involved, maybe you're like an open source guy and want to do more of that, or you have a pain point. There's activity here, and there's a lot of eyes working on this problem. And I think that there's a lot of opportunity for people to contribute.
Thank you, Jonathan. Alan, I'll give you the last word.
Well, really fantastic job, all you folks, and great points. It's not enough time to make all the observations that could be made, but I just want to advocate for a couple things. One is, I mentioned earlier, to Greg's horror, the xScale computing project's E4S single container is not intended to be deployed that way. It's just a package for the built stuff that you can use for testing. I think there'd be value in us doing something like that, aimed not at the xScale stack, but at a typical HPC stack. And what I've done to try to facilitate that is I've gotten a hold of all of the CI/CD steps that they use. Some of them are internal, but we could reproduce that. We could actually, to pick up Jonathan's point, we could get a community effort going to build a typical HPC stack that you could, if you just wanted to get started, download the container, try it out, and then go back to the recipe and build, because we'll include the recipes, build what you want. So I think that there's value for the community to try to reproduce what E4S has done on the local scale. And then I just want to bemoan the loss of the Singularity Hub. In practice, I see a lot of people's workflow, because we only support Singularity on or Aptainer on our clusters, is to go and pull the Docker container into Singularity. So we're relying on the Docker Hub. Is that the right way to do things? I don't know. So I think we should look at having a community resource for building and maintaining Singularity containers as well. I'll stop there.
Oh, that's a great point, Alan. We've been talking about that quite a bit inside. I know Dave's been talking about that a lot. So really appreciate it. Thank you guys for joining. Our time is up. It's actually a little bit over. So thank you for joining this week. Looking forward to seeing you guys next week. Please go like and subscribe, and we'll see you soon.